Oh my gosh. I'm so annoyed about this AP Chem project. All I want to do is talk about the dire state of the world right now.
Sage, quit whining. Let's learn about the chemistry behind allegedly the best alcoholic drink, wine.
Hold your horses! Is that school appropriate?
Yes, it is. Hey kids, don't do underage drinking. It's not good.
We are Sage and Adanya, partners in crime and partners in wine.
Prepare for the best 10 to 20 minutes of your life, because we are about to delve into the inner works of the creation, content, and chemistry about a glass of wine.
So for the process of grapes actually growing, before wine can be made, the grapes take about 5 months to fully develop. The vine starts growing in May, and then normally the grapes are ripe by October. Grapes create energy by photosynthesizing. This converts light from the sun and carbon dioxide in the atmosphere, and lastly water in the soil, into energy stored in glucose, and then it also releases O2 into the air. The process of how nutrients go up through the roots is that plants release acids that bind to metal ions to free up negative ions in the soil, and then those grab one form of active transport.
Now, here's where it starts to get crazy. Hold on to your socks, ladies and gents. As you can see from this vine right here, notice how it's bending towards the light? Gee, I wonder how that happens. Yep, okay, thank you. Good morning. My name is Sage Hopwood. I'm going to assume none of you understood what was just stated in the previous clip because it was complete gibberish and completely wrong, as I was flustered and didn't know what to say in the given moment. Now, phototropism really isn't all that difficult, however, I managed to say the wrong thing entirely. I will not lead you astray, and I will delve into the chemistry of what phototropism really is. Step 1 in phototropism is, of course, light perception. In phototrophin proteins, a molecule called flavin mononucleotide, also known as FMN, is not covalently bound within specialized domains known as LOV domains, which stands for light, oxygen, and voltage sensing domains. When blue light hits FMN, it absorbs a photon which causes one of its electrons to jump to a higher energy orbital. This is the excited state of FMN. In this excited state, FMN becomes chemically reactive and is able to form a covalent bond with a nearby cytosine residue on the phototrophin. This bond causes the protein to change shape, which starts signaling cascades inside the plant cell. Step 2 is auxin redistribution. The signaling cascade triggers a redistribution of the plant hormone auxin, moving it towards the shaded side of the plant stem. So in other words, auxins are much like me in 2020, thinking emo was being cool and living on the dark side was edgy. Step 3 is auxin action on the shaded side. Auxin activates proton pumps in the plasma membrane of cells on the shaded side. These pumps actively move hydrogen ions into the cell wall, making the cell wall more acidic. Step 4 is the acid growth hypothesis. The lower pH in the cell wall activates proteins called expansins. Expansins break hydrogen bonds and other linkages between cellulose and hemicellulose. This loosens the cell wall structure and makes it more flexible. Step 5 is ion movement and water uptake. Auxin also stimulates potassium channels, allowing potassium ions to flow into the cell. The accumulation of potassium lowers the water potential inside the cell, causing water to flow in by osmosis. This increases turgor pressure, which pushes against the loosened wall. Step 6 is cell elongation and bending. With the cell wall loosened and turgor pressure increased, the cells on the shaded side start to elongate more than those on the light side. This causes the plant stem to bend towards the light in a process called phototropism.
Also, chlorophyll absorbs blue light and reflects back green light, which is why this sapling has a blue shield around it. It's to reflect back that green light.
Trigger warning, biology incoming. Now I'm gonna dance around this subject because I know nobody wants to hear about it, and I know it's a tough subject. So what happens is, water is polar, we all know this. And so what happens is the water will stick to the xylem of the stem, which causes it to stick to that, and then water has cohesive properties as well, which cause it to stick together. So now, if the adhesion is stronger than the cohesion, it causes capillary action, allowing the water to be slowly brought up through here and perspire from the leaves. A true friend is like a bottle of wine, reliable and always there when you need them most. They may not fix everything, but they sure make life a little easier to sip through. fermentation of grapes. What happens is we'll start with glucose and fructose, and we will then put in yeast, malic acid, phenolics, and water, which will then go through C6H12O6 plus catalyst yeast, goes to make 2C2H5OH plus 2CO2 and energy. Now, glycolysis, the entire thing is C6H12O6 plus 2ADP plus NAD plus makes a pyruvate C3H4O3 plus 2 ATP and NADH. Now, what happens here is the pyruvate will then... Let's retrace our steps here. Hello again. It's me. I'm guessing the last clip was a little convoluted and you didn't get much from those segments. Well, don't worry, I'm here to clear the air. What really happens during the fermentation of grapes? Well, it starts with glycolysis, which turns glucose into 2 pyruvate molecules. This reaction is C6H12O6 plus 2NAD plus 2ADP plus 2 inorganic phosphates make 2C3H4O3 the pyruvate plus 2NADH plus 2 ATP plus 2 H2O plus 2 hydrogen ions. The overall of this is the glucose will be split into 2 pyruvates. 2 molecules of NAD plus are reduced to NADH, and 2 ATP are made directly. Now, of course, if you learned anything in your regular bio class, which many of us may not have, fermentation does not go through the mitochondria, rather it stays in the cytoplasm. The next steps happen because the yeast needs to get the NAD plus back, or else glycolysis can no longer happen. So now what will happen is the pyruvate will be converted into acetaldehyde. This happens by pyruvate decarboxylase, which removes the CO2. 2C3H4O3, the pyruvate, makes 2CH3CHO, which is acetaldehyde, plus 2CO2. This makes the overall of the equation C6H12O6 plus 2 NAD plus 2 ADP plus 2 inorganic phosphate plus 2 hydrogen ions makes 2C3H4O3 plus 2 ATP plus 2 NADH plus 2 H2O, which makes 2 CH3CHO plus 2 CO2 plus 2 NADH plus 2 hydrogen ions, which makes 2 C2H5OH plus 2 NAD plus. Or the net ionic equation, which would be C6H12O6 makes 2C2H5OH plus 2 CO2. I will now retire my duties back to Sage and Adanya to explain the rest of the interesting story of how to make wine. NAD plus to go through it again.
Now in English, factors that may affect the fermentation of wine are temperature and pH that can basically cause unfolding of enzymes necessary to catalyze reactions, as she was talking about.
Since protection is so important, potassium metabisulfites are our #1 friend. This is also known as K2S2O5, which protect from oxidization by releasing SO2 since it will ionize into 2K and S2O5, and too much will cause allergic reactions, but we don't really care about that. But potassium metabisulfites are really to bind with bacteria to allow them to no longer be able to eat with anything.
And for tartaric crystals, basically tartaric acid in wine will bind with the potassium that is from the potassium metabisulfides, and then it will form a precipitate. It is not harmful, but it is a fault or mistake in winemaking. So to get rid of this, we will freeze the wine and make sure all of the potassium binds with the acid, and then filter the crystals out from there.
All right, ladies and gentlemen, now the real show begins. This is a spectrometer, not one of the cheap ones in your chemistry class. Sorry, Dollars.
This one actually works.
This one will actually, what you do is you get your samples of wine, and then you'll put in things from these testing kits, depending on what you're testing for. Always keep these refrigerated. But then, once you put in a little bit of that, you will then, using our micropipette, here's the cuvette, you will then, it will bind with whatever you're testing for, so that when it goes into this, it can test for how much of that color was produced. And then it'll come out with a printed thing telling you how much was in there. This thing tests for acidity, this tests for malic acid, this tests pretty much everything, alcohol content. And why do we have to do this? The government. The government is the reason why you have to regulate these things, so that way when you send it to TTB, which is the one who regulates your labels, it shows that you're not lying. But in reality, you don't really have to do these tests because it's not really regulated very well. But we do it anyways because we're good Samaritans.
Oh yeah. What do you do when you see a really hot farm girl? A tractor.
This is a flips. What are you talking about? You're
Yeah,
not a real farm boy. Just get out of here. Just,
Do you
you
need
gotta
one of these
leave.
to get
Just
out of your bed
here.
every
I don't
morning?
even
Do
care.
you need one to get to the fridge?
You just
to
don't
get
even
your
appreciate me.
six-pack of
I'm
beer
done.
every
I'm
day?
done.
Jiminy crickets!
Unlike wine, my husband only gets more bitter with age.
I hate you, Gertrude. When I met you, you were just a grape, and now you're a raisin. We've heard Sage. Okay. Now that we've heard this guy blab on about chemical this, chemical that, let's get into the taste of wine. So basically, the thing that gives wines their distinct taste are called tannins, which are made of two classes of phenols, flavonoids and non-flavonoids. When flavonoids polymerize, it causes tannins, and the tannins bind with proteins in your saliva, yuck, I know, become insoluble, which is what gives it that tannic sensation and makes wine have a unique flavor.
Now, again, we have no experience with tannins binding with the proteins in our saliva, as we have never drinking any of these beverages before. Wines get their names from the region they were made in, and also the type of grape that they're from.
Now, we all know that temperature has a big effect on the rate law constant K, but it also affects winemaking. So wine changes based on whether it is cold or warm, and warm often disrupts the chemical structure and leads to oxidation, which gives wines different flavors.
Chilling a red wine leads to more tannic flavors, since at lower temperatures they are less soluble and bind more readily to the proline-rich proteins in your saliva. At warmer temperatures, not too much that can lead to oxidation, but it'll lead to more aromas that can distract your brain from the astringency. Aromas are much more important than taste. Taste is limited to 5 profiles: sweet, salty, bitter, sour, and umami, while aroma has hundreds of volatile compounds that travel through retronasal passages.
Umami. We all know the feud between Kendrick Lamar and Drake, and DJ Khaled and Salad are really passionate and filled with a lot of anger. But the differences in the feud between red and white wine lovers goes way deeper than that.
Red wine is made from red or black grapes. These grapes are crushed whole, meaning the skin, seeds, and stems are removed before fermentation but crushed with the grape. This means that there is no waste. Red wine is also matured for extended periods, which gives them a deeper flavor profile.
On the contrary, white wine is typically made from white grapes only. It is fermented at a slightly lower temperature, which slows the aging process, which means that they're also less mature, so sage. And this results in a lighter flavor profile that is floral and citrusy, and they also have a naturally higher acidity level that leads to a tartar, more bitter taste.
Common types of wines are white sparkling champagne, prosecco, cava, and moscato, and for white unsparkling is Chardonnay, Sauvignon Blanc, and Pinot Grigio. Red sparkling we have Lambrusco, and red unsparkling we have Pinot Noir, Merlot, and Cab Sauv.
If you're over the legal drinking age and are wanting to get the most bang for your buck, the wine with the largest alcohol content is sherry and port, which is about 16 to 20% alcoholic content. And then the least amount of content is light white wines like Prosecco and Moscato, which are about 11%. Like Drake, wine has struck a chord in the hearts of many all across the world, especially miners. Wine has shaped civilization for years and years and will continue to do so until the sun explodes. Wine serves as a symbol of community, and economically, the global wine industry generates billions annually, supporting millions of jobs like Sage's. She would be unemployed.
Today, the fermentation of grapes continues to blend tradition with technology, fueling sustainable practices, local economies, and global commerce while preserving a deeply rooted cultural legacy.
Thank you for watching this show. Sage and Adanya are out.
Now that we've heard about sage, blab on about different chemicals like who gives a dang about potassium metabisulfides, whatever. Okay, anyways.
Here are the sources. Ta-da!